this tutorial I'm going to discuss about OSPF. So OSPF, how to enable routing via OSPF. So OSPF is open shortest path first. Open shortest path first is the way to enable routing. But when we configure routing, we with this method, the basic concept of OSPF is that it creates an area in a wide network. For example, this network is dealing with areas in a wide network. For example, this is wide network, and via OSPF, this router network become one area. This router become one area. This router network become one area, mean area 1, area 2, area 3. So a nice concept to work on a WAN network, and this is where the OSPF works configure on, that we configure a area, we distribute it in a network in an area, and via the network we configure routing. So where's the command? This is a bit different than other routing protocols. We have a command called router OSPF space AS number or process ID, you can say, autonomous system number. So the range is 1 to 65,535. Router space AS number, process ID. The next one will be network space network IP space wildcard mask and area space area ID, whatever area ID wants to be. Now wildcard mask is a very tricky thing. We learn about wildcard mask, putting wildcard masks, but wildcard mask is to find out wildcard mask is equal to broadcast ID minus the wildcard mask equal to broadcast ID equal to your network mask or subnet mask. Network mask, net ID, net mask. So for example, your broadcast ID is 255.255.255.255, and the network ID, network mask is, for example, class A's network mask is 255.0.0, and when you minus those values, then you will find the equal is 0.255.255.255. This is what wildcard mask is all about. We already learned about that. That is a kind of it's equal. It's opposite, not equal. It's opposite to the class network. For example, for class A, this is a wildcard mask, so it's opposite to your network mask. 255.0.0.0, 0.255.255.255. So this is what wildcard mask is. Broadcast ID is 255.255.255.255. So this is what if you want to know about a wildcard mask of class B, then 255. So you have to put a 0 here. If you want to know about the class C, then 255. So 0, class C. Basically, this is where the values, and so For working style, we always either select class A or class C mainly to configure network. And although if you are doing subnetting, then no matter, just use subnetting mask. But if you are not using subnet mask, then sometimes you have to use wildcard mask, like in this case. So this is where the wildcard mask concept is, that wildcard mask is equal to broadcast ID minus network mask 0.0.0.255, and this is where broadcast ID network mask, the network ID. Okay, so now let's configure it. So config T router, now OSPF, and whatever AS number he wants to use, process ID, we're going to give 10, then network 10.0.0.0 0.255 to 255 to 255. Area wants to give is 0. And 0 area. Now area ID, whatever he wants to give. Now here another network wants to add is 192.168.1.0. Now here this is a class C, so 0.0.0.255 and areas equal to 0. Let's be at 10. Now here in this router, for example, oops, sorry. Now we're broadcast. Config T. Now router OSPF. Now the value 10. Network. And then here we give a value called 20. So 20 0.255 area. For example, I want to give an area called 2. Network, and then 192.168.3.0, so 2.0.0.255 space area 2. Here in the router, all done. So let's configure it. Config T. Now again OSP router OSPF, then process ID 10, network stands network 0, then 0.255 to 255 to 255. Now here you have to create an area, whatever area you used on 10's network. So make sure you hit area value is 0. Okay, because we are using 10 as area. Okay, so now area here at 20, full loading is done. You can see here. Now for 20, we give a value 20. Sorry, it's area 1, area 2 actually. So change from area 0 to 2. So 20's network is now area 2, and you can see it's loading. It's load done. So what we done is network 10, we divided that network 10 to area 0, and we divided network 20 to area 2. And then for a fast Ethernet network, which is 192.168.2.0 and then 250.0.255, area will be 1. Okay, so all done. Now I think all done. Let me just do PC. Yes. So let's try to ping with our router network. Doing. Okay, so here we go. Start pinging with our network. So we were to ping with, for example, 192.168.2.2. There we go. Start pinging 2.3. So we just divided an area, and according to it, our communications are happening with network. For example, 192.168.3.2. Oh, sorry, ping. There you go. Similarly with this PC, pinging with 192.168.1.2, pinging 3, pinging 2.3. Even you can ping with a serial port, pinging. So the OSPF thing is that we basically divide a wide network in an area. I divide this network in an area 1. Area 0. I took this network as area 0. I took this network as area 3. I took this network as area 1. Okay, so area 0, area 2, and area 1. And according to give a command, so that we configure OSPF. So router OSPF 10, the network ID, Wacom area ID, then the fast Ethernet ports ID, Wacom area 0. Then similarly in this router, we divided on an area, and you can change area according to it. For example, before we give us ID as 0, then later we change that ID to 2. So doesn't matter, but that area ID basically the routers written those area IDs in their MAC table, and they knows what they're doing. On the routing table, they written what is going on, what is the area ID of which network. So they very much noted. They very much noted that which area ID consists which network, and they very much note those in their routing table. So this is what OSPF is all about, a basic routing configuration via OSPF, where we configure OSPF and then network ID. We divided that network ID into area. So hope you learned something from it. Thanks for watching.